For this lab, we will be exploring traditional strings and their limitations for our word processing application. So, what the heck is a string anyways? Strings are really nothing more than a collection of characters, and in many languages, they can work very much like an array. In fact, that is almost exactly how the C programming languages handles them. C Sharp is very much like Java, and I like to say about 60 to 70% Java and maybe 20 to 30% Microsoft. But all things in C Sharp are objects. For example, the integer data type that you're so used to is just an alias to the system.int32 class. So when you write int, all lowercase, in C Sharp, that is just an alias to the system.int32. Very similar idea for strings. So the lowercase string representation is simply an alias to system.string. And in fact, when you try to use the string data type, you actually have to import or add the using statement for system, unlike many of the other data types in other languages that you would consider as a primitive type. Unlike some other languages, this means we actually have to import the system library to gain access to some of the data types that others would consider as a primitive data type. But which should you use? They're completely interchangeable. However, it's better practice to use the lowercase version of the data type when declaring variables and the capitalized version for accessing static properties or methods of the class. For example, the string format method. But let's take a closer look into strings as a data structure. Strings are what we refer to as an immutable object. Immutable objects or data are unable to be modified once they've been made. Now, you've all probably concatenated or added strings together before. While it appears that you're changing the original, you're actually creating an entirely new string object as a result. In this process, all characters are copied from the old string and combined with the new string that you're trying to add. This forms an entirely new string object. For most cases, this works just fine, but for a large number of characters, this is extremely inefficient. That is why we have string builders. They operate just like strings, but are mutable, so there's a lot of time saved behind the scenes when you're actually modifying data, because there's not a new object that's created every single time the data structure changes. One of the easiest ways to build your string is to use the append method. Let's take a look at a few ways on how this actually works. You can initialize the string builder with an empty string, or you can actually simply use a string variable like I do here, or just place the string directly into the constructor when you create the string builder. Once you have created the string builder, all you have to do is simply use the append method to add characters or whole new strings to the string builder. If you ever need to get the string back out, all that is needed to do is call the toString method on the string builder, which returns the resulting text. So the hello world string is what I get as a result. So I start out with just hello world without the exclamation point, and then I simply append the single exclamation point to the end and convert it to a string at the end. So when do you use strings and when do you use string builders? And this is quite debatable depending on the programming language you're actually using, because each programming language actually has more efficient ways of string concatenation depending on what you're actually doing. But for C# in general, when you want to use string builders, you'll want to use them when you're making frequent changes to a string. So for example, if you're using or changing a string inside of a loop every single time the loop iteration turns, you'll want to probably use a string builder. Or if you are concatenating the same string over the course of multiple conditional statements, you'll probably want to use a string builder in that cases as well. Likewise, if you're creating a service and you have a very long running change across a large time span, you'll also want to use string builders. String builders also avoid the creation of temporary strings as well. But when do you want to avoid string builders? Because sometimes it's a little overkill. So when your string never changes, there's no real reason to use a string builder over a string, because you're creating a new object just like you would with a plain string, and if there's no changes, you're actually adding a little bit of extra overhead using the append function and the extra time that it is to create the string builder object. Now, You don't necessarily have to use the string builder like I did before in my simple example when I attached only a single character to my string. So for simple concatenations, like some other ways that a string builder is actually avoided is sometimes your compiler is actually smart enough to make simplifications for you. So for example, if you have multiple concatenations like I do here, where I add DE and then I also add FG to my string, the C# compiler will actually simplify this process or improve this code by actually converting it to a string.concat call. This will actually simplify and improve the speed of your operation. Now, the compiler isn't always going to be able to optimize your code in this fashion. So just be careful when you're actually doing these simple string concatenations. Sometimes it does make sense to use the string builder. Other times, you just need to write a little bit more efficient code if you reduce the amount of lines that you actually have. In the lab today, you're actually going to experience some of this slowness when you're using plain strings versus string builder. So we'll implement both and then give you some sample text to run through your word processing applications so you can see the difference in efficiency.